Welcome back. In this set of videos, we're going to be looking at piecewise defined functions. Before we jump into piecewise defined functions, we want to talk about what functions are in general. I think of functions as being like a machine. We have a series of inputs x, which we are going to call the domain, and there are some restrictions about what is allowed to go into this function. And then based on what is allowed to go in, there is going to be some rule or something applied to those values or some relationship that is going to generate outputs. The outputs are going to be considered the range, what's possible to get out. Now, for something to be a function, for each domain, for each input, there is only one output. So that is what makes something a function, and we're going to be thinking about this. So when we use function notation, instead of writing something as y is equal to 2x plus 1, we replace y with f of x. And in this example here, we're going to look at why we're actually going to do this. So if I have y equals 2x plus 1 and I want to evaluate it for x equals 0, I do y is equal to 2 times 0 plus 1, y is equal to 0 plus 1, y is equal to 1. Now if I want to evaluate it for x equals 1, I have y is equal to 2 times 1 plus 1, y is equal to 2 plus 1, y is equal to 3. There is nothing to connect which x value this y relates to. When we're looking at a function, we want to connect our input to the output. We have paired values, and it's really important that we keep them together. And I have no way, when I look at my paper, of knowing that y equals 1 is paired to x equals 0. When we're using function notation, we get, so I have f of x is equal to 3x minus 1. I want to evaluate this at x equals 0. So everywhere I saw x, I'm going to replace it with 0. So now I have f of 0 equals 3 times 0 minus 1. F of 0 equals 0 minus 1. F of 0 is equal to negative 1. So now I have my x value paired to my y value. I can then evaluate it for x equals 1. F of 1 is equal to 3 times 1 minus 1. F of 1 is equal to 3 minus 1. F of 1 is equal to 2. So now you can see that my x value and my y value are paired, so that it's not just y equals negative 1, y equals 2. It's y equals negative 1 when x equals 0. Y equals 2 when x equals 1. The other thing this allows me to do is to have multiple functions defined. So I have f of x equals 3x minus 1, g of x equals 1/2 x plus 7. So now, if I evaluate g at 0, I have g of 0 equals 1/2 times 0 plus 7. G of 0 equals 0 plus 7. G of 0 is equal to 7. So now I'm differentiating between these two different functions, these two different machines. I have the same input going into two different machines, and I'm getting a different output. And I can distinguish for a single function that these y values are paired with these x values. But then for this x value and this function, I get this y value. So g of 1 is equal to 1/2 times 1 plus 7. G of 1 is equal to 1/2 plus 7. G of 1 is equal to 7.5. So it really is going to help me keep things straight. In our next video, we're going to introduce piecewise defined functions and start kind of thinking about them.